Hi, my name is Greg Wilkins. I'm the handicapper at Manly Yacht Club, and this is a very quick and rough video to introduce you to a project that I've been working on to help analyse handicaps and analyse how boats are doing. This is an analysis I've done sort of informally at the end of most seasons for the last couple of years, but with AI being available to help me code up a website, I've now put this into a website, sailing.mortbay.org, which is running off a Raspberry Pi in my cupboard over there, so be gentle, that anyone can play with and see if there's any value in what I'm doing with this analysis of keel boats racing in the Australian fleet. So the first thing I want to say though, that this is not PHS. This is not a replacement for PHS racing. It's just an analysis very similar to PHS. The key thing is why it's not PHS is this is on the whole fleet. It calculates time correction factors are influenced by what's happening in Western Australia and Northern Territory, unlike PHS, which is looking at your series within your club. So you could not race and something significant could happen in the data in South Australia, and it will change the performance factor you get, which is not easy to explain to your skippers. It's not week by week. This is much better at analysing bulk data at the end of the season to look at next season. It's not designed to give you, oh, this race finished, your handicap changed the next week. Maybe it could be used for a fixed handicap for a season, but let's not go there because it's also not PHS because it's experimental. It's almost certainly wrong. It's going to change. It's not a handicapping system. And it's also non-deterministic. It's got an optimization phase in there, so it does a little bit of random numbering jiggling. And again, it's very hard to explain to a skipper why their handicap is a certain number if it's got random numbers in there. Hopefully it will converge to a sensible solution, and this system will show you that the factor is correct, but it's no guarantee, especially at this early stage. And also there's no punitive element in there. Some PHSs are set, so if you win one race you'll lose next week. No, this is trying to average out across all boats in all clubs over the last 5 years at least, where I weight recent races more than old races. And it's intended as a tool to analyse rather than to actually allocate handicaps. Well, a tool to help allocate handicaps that go into a PHS system. And the approach it takes is a statistical approach where we're looking at time correction factors that are weighted. And so this is a fundamental thing, so I'm going to go a little detailed straight off the bat. The way I combine time corrected factors is a weighted calculus. So if I'm measuring, here's a plot of a time correction factor, and these measurements all coming around 104, but they've got low weight. They're not very confident. The race was a bit jiggly, the certificate was old, or whatever the source is, it wasn't seen as a very good source. But if I aggregate them together and they're all coming in at similar values, then the resulted aggregate value has a high weight. It's going to be the average of all these values, but a high weight because they were quite similar to each other. On the other side, if I'm getting discord, if I'm measuring the same time correcting factor in different ways for the same boat, and I'm getting wildly different values, even if each individual has a high weight, so here's 0.9, weight 8.5, then when you aggregate them together, you're going to get the average value from those, but it's going to be given a much lower weight, much less confidence. And you'll see that this weight maths goes throughout the entire system, so the final numbers that you get can have color codes or the weights known or error bars, so you can judge, oh, that's a number, but what's the confidence in that? And so that's the statistical principle behind this. The more ways I measure a time correction factor and get the same value, the better confidence. The more variation I get, the lower confidence. Okay, so what's the data sources I'm using to do this? You can see I've got 92 clubs, 2,500 designs, 12,000 boats, 2,500 series, and 18,000 races. Well, Where this is sucking data in is it goes through any public measurement certificates you can get, ORC, AMS. It doesn't grab the IRC ones directly because they've got a robots.txt that says don't do this. But I do get IRC values, not the certificate, when they're published in a race entrance elsewhere. And then I look through the Blue Water Points score because it's very good across fleets and a lot of the boats have measurement certificates. I get South Cis races and Top Yacht races. And what I'm grabbing from those, just from the published results, I grab just the elapsed time and any measurement certificates. I'm not grabbing any personal data. I'm not grabbing even the results. I don't care who comes first, second or third. I don't grab any allocated PHS. I ignore all of that. That might have policy, might have proprietary information in it. All I want to know is the elapsed time. And that's the basis of all this analysis, the elapsed time. What I use the certificates for is just basically as standard candles so that the resulting numbers we get are comparable to other numbers outside the system. Don't use them to actually calculate the factors, and then just to calculate the factors is really just based on the elapsed times. How did boats go against each other in elapsed times? So the other big thing is when I import the data, a lot of effort has gone into cleaning the data. So if I say look at the boats, people are entering different, sail numbers, lots of 0 sail numbers, lots of 1 sail numbers. Names are misspelt, or there's numbers in there. Let's see. We get multiple boats with the same name. Let's narrow this down. We go to CYCA Club and we look at their boats. So we can see that there's 2 boats called Yeah Baby here, but they're different designs. So they're probably different boats, so I'm not going to merge those. Let's go the other way. Here, About Time is the same thing. 3 boats called About Time of 3 different designs. But here I have Adam Magpie. It's an Etchell, and the only difference is the sail number. So that's probably the same boat, or with an Etchell, maybe it's a different hull, but might as well call it the same boat for this analysis. So if you see something in the data like this, we can actually request to merge. So anyone can do this, send in a request to merge. If you're logged in, you can actually do the merge. You can say, I think these are the same boat, blah, 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 request to merge. And we'll merge those in and clean the data up. Not only will we merge them, we'll remember the difference that caused that merge as an alias or some other thing, so that when we re-import information in the future, that merge keeps happening. If something's just out and out wrong, we can actually request an edit, where we can change the sail number, we can say what the actual design is, we can say it's not this club, and again, give your email if you want, and a reason if you want, and request it. And so that's an effort to clean the data up. Again, we remember those cleanups and we apply them again in future. We can do that for boats, we can do that for designs, we can edit designs, we can merge designs and clean the data up. So a lot of effort is done to clean that data up. Once we've got that data, let's see, similar things with certificates. We start analysing the data. The first thing I do is I go through and I compare any boat that's got multiple certificates. I can look at how you transfer the values from one certificate to another one, and I build this, massive graph of how I can convert a 2021 ORC certificate through all these different links to an IRC 2025 certificate. Because that's currently my target. I'm targeting 2025 because not everyone's got 2026 yet. And IRC. I think eventually I'll probably go to ORC in 2026 as the target. And it's just nailing the value so you can compare it. And then each of these legs, I can say that from IRC 23 to 24, you can see there's a very good correlation. So the table has very high weights for if I do a conversion that way. But then for some reason, say ORC from 24 to 25 has really low weight. And you can see why is that there's a real, this is plotting certificate versus certificate, the two certificates. There's a real, non-correlation, non-linear. Looks like there could be a line here and a line there. So I'm not convinced it's not a data import problem, that maybe I'm mischaracterizing a Spinnaker handicap as a non-Spinnaker one. I'll look at that as time goes by, but at the moment it doesn't matter. This goes into the system as a very low weight. So it's probably wrong, but low weight, it'll get factored out. So what I do is I take every boat that has a certificate and I convert that certificate into our target IRC 2025 time correction factor. And that's what I call an initial reference factor for those boats. And the reference factor is kind of like the measurement of what the design should be doing. And so we can look at our boats, and again, we'll just limit to CYC for now, A boats. And we can look at by their reference factors, and we can hide the empty ones. Not everyone gets a reference factor, but we try and give everyone a reference factor. Either you have a certificate, so you have a Gen 0 reference factor. It might have a low weight if once we combine all the different paths through that graph of all your different certificates, if they converge to the same value, you'll have a high weight Gen 0. If they don't converge, you'll have a low weight Gen 0. If you don't have a reference factor from a certificate, then we look at your median results when you race against boats that do have certificates, and we give you a Gen 1 certificate. So here we can see Novo has a Gen 1 Spinnaker, a Gen 1 non-spin, and a Gen 7, which I think is the limit for two-handed. So it hasn't raced against a two-handed boat. And we can see by hovering over, the greens are moderate confidence, that's dark green is high confidence, grey is 50-50, red is don't believe this number. And so once we've given an initial reference factor to every boat we can, there are going to be some boats that we don't because we've excluded them or they're in islands that haven't raced against things. We then aggregate all the reference factors for boats of the same design to get a design reference factor, and then we flip it back the other way. We take the design reference factor and apply it back to all the boats of that design to make sure that we sort of bring outliers in a little bit. And so that's the reference factor is a time corrective factor for what we think the boat's design should go to. And it's a very deterministic process. The algorithms clearly step by step. There's no randomness in there. There's no optimization in there. And it's really the design-orientated handicap that we're meant to get. Once we have that, we can then go to every single race in the database, and we look at the reference factors for boats that did that race, and we can calculate a reference time for that race of what a boat with a hypothetical boat with a 1.000 handicap, what time would it take to finish that race. And the reason we need that is that we don't have the length of the course, we don't have what the weather was, we don't know anything about the race other than the elapsed times of the boats that did it. So we use the standard candles of boats with certificates to get reference factors for everybody. We can then guess how long a 1.000 boat would do on that race. And again, that guess will have a weight associated with it. And then once we know what a hypothetical 1.0 boat would do, we can then start looking at how boats actually did against that. And then we can start doing back calculated factors for the boat of what did it achieve in that race. And so if I look at a boat, one who's done a lot of races, here we go, Marauder, and we can start these scatter plots of here's the factor that we've eventually assigned it, and here are the races that it's actually done over time, ones with high weights and ones with low weights. What we do to get the performance factor, which is the one for the boat itself, is we then do an optimization process over the entire fleet, where we jiggle the the factors assigned to boats around a little bit randomly in various ways in order to try and make the minimum residues across the entire fleet. What's the best set of factors to give the most even response across the entire fleet? And that's where we get our performance factor from. And so every boat gets a performance factor. If we see in CYC, the high ones here, we've got our Law Connect, those probably should be merged. Wild Thing, you're going to get Wild Oats in here, scroll on down. Well, TP52s are coming in here. And yeah, so that's our performance factor. So once we've got our performance factors, what do we do with it? How do we use this as a tool? We start looking at saying, is it a good performance factor? Does it really represent a good time correction factor for a large set of boats? So in order to do that, we have to start looking at races. So let's go look at some races. Let's look at the recently done Sail Port Stephens. Let's look at Monday on Sail Port Stephens. So we can do a plot like this. What this plot is showing is that I've plotted all the boats here with their performance factors. So this is a fast boat, Ammonite. Here we have Little Nico, Condor. So this is obviously Div 1. And Banter, Seahawk, Llama, first project. Where's Jambo? Oh, Camricky. I was on Camricky. And what we'd like to see is the dotted line, dash line, sorry, is their actual elapsed time plotted against their performance factor. So you're going to expect to see the boats with high performance factors take less time than the boats with lower performance factors. So you can expect this line to be sloping down. The better the performance factor, the more straight this line is going to be with less ups and downs. But some boats already have good days, low, and bad days going fast. So on any individual race, we expect to see some jiggles, but systematically when we look at lots of different races, we'd like to see this smoothed out. And then we sort of show the same thing by applying the performance factor to get a corrected time, and we plot the corrected time here. And so we expect the corrected time is trying to get every boat to have the same corrected time. If a performance factor is correct, every race should be a draw. And so we expect to see flat lines here if the number is good. And we can put a trend line in. Which you can see that here it's going up a little bit. So this race is saying that, well, the factors that we applied favoured the slow boats more than the other boats. And just before we, if we put this from 0, you can actually see the real chart there. The charts zoom in. So this is coming from 0 minutes to, they took about 150 minutes, 2 and a bit hours, and zero factor, we don't have any boats like that, up to the top ones. And we can look at the different divisions in here. Oops, that's a bit of a slope there. You can see that all these divisions, the slow boats were favoured. Well, that one's quite level. That's quite a nice one here. And you see the crossover for division, non-Spinnaker, crossover here is around 1.0, where the correct time is the same as the elapsed time. Let's zoom in again. And we can look at the next race. Okay, so the slow boats were not favoured in that one. Slow boats not favoured. I've gone to sports boats. Oh, I'm looking at different series. Let's go Saturday here. And we can look at each race in turn. So slow boats were favoured in race 2. Wednesday, slow boats were favoured again. And so what we want to do is look in aggregate over the whole series to see, did the performance factor work? We can zoom into an individual race. Oh, before I leave here, I can say we can also look at the reference factor, how that would have worked if we did it on a design basis. We can put error bars in there. It's a bit experimental. Just trying to show the weights. Just adds noise at the moment. But then we can zoom into the actual series itself. So here's a plot looking at the series of all the 1, 2, 3, 4, 5 race days that were done, and we can see what the overall trend, the dotted line, was for all races. And again, so it looked like this week was favouring the slower boats in Div 1, in Div 2. The slower boats were also favoured. And again, this is not the results of the regatta. This is the results as if these performance factors that were generated by this system were applied to that race. And these performance factors are the same performance factor for a boat for all regattas. If it's sailing female helm, all female. If it's sailing offshore, inshore, so it's an almost certainly wrong single number performance factor. But you can see how it goes, and it's I don't think it's doing too bad here. So once we've got a feel for the quality of the performance factors, now we can start using them to assign actual handicaps. This is where this analysis turns from interesting into a tool. So I can actually go look at compare boats. And let's look at my own boat, NYC 32 Esprit. It often races in twilights against, say, Mondo and Absolute. It also does weekend races against these boats. And here we're comparing these three boats. And so what we get here, it's a bit noisy. I'll take off the RF line and the linear trend and just leave that. So what I've plotted here is those three boats, and we can have as many boats as we like in here. The dark lines is the performance factor that the system has optimized for them. The dots are how the boat is going against it. And the dotted line is a very rough PHS simulation. It's showing the best of your 7 of your last 8 races, but without any caps or cutoffs or exclusions. So it's a very rough PHS simulation. And what it's showing you here is the way we do our performance factors is that we actually punish good results better than bad results. The way we think about it is that a boat that occasionally races faster than its median is actually saying, oh, it actually can go better. If it's just once, it's a luck. But if you're regularly going a little bit faster, it means you're regularly sailing below your capability. Whereas, a boat which is regularly high and dropping off every so often, it's very easy to make a boat go slow where you can't make a well-sailed boat go faster. So we set the performance factor at what we think the capability of that boat is. It's still performance-based, so it's still with the crew, average sails with the sails it's got, with the average state of the bottom. It's not a measurement factor, but it's showing you the aspirational performance factor for that boat, and so a PHS will normally bump along underneath it. We can also look at the trend lines and say, oops, let's zoom in a little bit. Is a boat improving or really improving? Who's that? Absolute's really improving. Or getting worse. Oh no, Esprit, my boat's getting worse. I've been overseas for a while. Crew who've been sailing their boat. What do you mean we're getting worse? Anyway, once we've got that, we can look at, again, this is doing each boat in pairs, looking at their absolute times against absolute times to see how good a correlation they are. How good a pair of boats are they for comparing handicaps? Do they consistently race in a good ratio against each other? And what you'd expect to see is a nice linear trend, and we plotted here the best fit, the RF and the PF. So the reference factor and the performance factor ratios between them. This is Mondo to Absolute, this is Esprit to Absolute, and this is Esprit to Mondo. And we expect the better the match, the more linear it is. And so what we can do then, we can use the handicap calculator, where we say, let's say Mondo in our handicap system, here we have the factor for the performance factor, reference factor, and the best fit factor. But if in our handicap system, Mondo was a 0.5 boat, it's now telling us what PHS handicap we should assign to Absolute and Esprit if we were looking at the PF or the RF or the best fit. In this case, they're all pretty much the same. And we can do this if we have even more handicaps. Let's say we knew that Esprit was sailing at a 0.98. Now it's averaging those out and giving what it thinks the absolute should be, whilst also giving a bit of a evaluation of how good these allocated handicaps match the ratios of these guys. And so we've added more boats. Let's say we say Pom Paddy, add boat, and let's look at non-spinnaker, and we're going to add in MYC 7, which was 1060, is now daydreaming, and put them, like, if we had daydreaming a really unfair handicap of 1-0, but Pom Paddy was 0.80, then we can see it's giving us that doesn't think daydreaming's one's very good, telling us what it thinks absolute should get, and sort of rates all the other ones. So this is where we can use this to allocate handicaps for an unknown boat. If Absolute had just joined the fleet, we can even go, if we went back to myc.org.au, we look at our series, we look at our Twilight series. There we can then, there's our Twilight series, or things we can compare all 39 boats. So we do enter in all the handicaps we've got. This will rate how good it thinks of them according to the various factors, and suggest missing handicaps or help you improve handicaps. And this can be used to set handicaps for next season. If a boat comes along and doesn't have any race data against it, we can do a similar thing with design. We can compare designs. So we can say, oh, I've got a Adams 10 has come along. Oh no, I know I've got an Adams 10 racing with me. Everyone's got an Adams 10 racing with me. And a Grand Surprise has turned up. That's how we think, they seem to be a reasonably good match. We can then say, well, if the Adams 10 was given a 1.00 handicap, then the Archambault should be a 102. And so we can start predicting the handicap. And so that's the idea of this tool, is to evaluate handicaps, spare chest handicaps, and to help use the analysed elapsed times across the whole fleet to give handicaps to boats coming in from other clubs. But I haven't stopped there. I've decided to try and extract every last little bit of information I can out of this data. And so a very experimental, it's all experimental, is I've got a performance profile for boats. So let's have a look at, we'll go back to, say, Middle Harbour Yacht Club. I'm going to look at all your boats. And I'm going to look at performance. I'm going to hide the empty ones. The performance factor, if I look at, say, I'll just pick one, Exile, is this little chart down here. And what I do is I rank every boat on 5 different spokes. How frequently do they race? And you get rewarded for more races through the last 12 months and more consistency. You're racing every month. And so you get a score, and we rank all the boats from 0 to 1, and that's where you go on this spoke. Then we look at your consistency. How much of a scatter do you have? You've got a lot of variance from here. You'll get a worse consistency score. If you're nailing in, if you're in the best rankings of nailing in fairly consistent results, you score well here. We then rank diversity. Are you just racing against the same 3 other boats week in, week out? Or are you racing against big fleet, lots of other boats, and frequently racing against big fleets and other boats at other clubs and things like that? So the more diverse your competitors, the higher your diversity ranking in. We then look at stability. How are your residuals changing over time? We rank highest if you're steady. If you're steady, haven't changed over the last 12 months, then you're not getting better and not getting worse. You're being very, you're probably near the boat's capabilities. Second best is that you're getting better. Throughout the year you got better and better and better. And worst of all is you're getting worse. So how stable are your results? And we rank those. And then I like the one non-chaotic. This is like, we can see when races aren't very good because everyone's residuals all over the place. And something you see when a boat's residual is big. the race that you're in, everyone's getting really weird results, but you've got a bang on target result, then you're not chaotic. It's like when the race is crazy, but you're consistent, you get a high score. Next best is when everyone's crazy and you're also crazy. If your bad results, your bad inconsistent results are when everyone else is having consistent results. It was a bad day for everybody. The wind was strange, something happened. So that's the second best in the chaotic things. Worst is if you're in a race where everyone's got bang on target results as expected and you've got the big variance. So you've had a bad day or a lucky day or something strange has happened to you. So you're a bit out of the things. And so the more that happens, the more chaotic you are. So we wrote about on chaos. And then we rank the boats by the area they get. So this sort of multiplies things. So if you're consistent and frequent, you get this big triangle in here. If you're consistent against a diverse fleet of boats, you get a big triangle in here. If you race against many different competitors and you're not chaotic, no matter who you race against, big triangle here, and that's the way it works. So the bigger area, the better performance profile you get. And so this is not going to be reward prizes at the end of any race, but it might be an interesting way to look at who's a good performing boat over the last 12 months. And this is all done over the last 12 months, which is why some boats don't get performance factors. And so at the moment at Middle Harbour, we're seeing advanced velocity is supposedly the best performance profile. So I'd really love to know if that matches with what you guys think. People are familiar with Middle Harbour. Is advanced velocity, Blue Tack, Gambler, Botany Access, Contentious Zen, Little Nico, are they the best sailed boats there? Walia, Onya, Toy Box, going down, scrolling down, and I'm sorry to name and shame, but is Rat Bag, Veloce, First Light, are they the ones that most infrequent or erratic or whatever? Is this a reasonable ranking of how boats have sailed? And of course we can do it across the whole fleet. We can say, if we look at not any individual club, we can say, actually advanced velocity is the best across the whole fleet in Australia. Marloo, Itchy, Mondo, Go Manly Yacht Club. And Mondo's been having a good couple of years, so that seems plausible. Shall I have a quick peek at the other end? No, that's cruel. I won't highlight those ones. So, let's just do a quick other clubs. Let's say CYCA, look at your boats, look at your best performance factor, Marloo, Shine On, Crosshaven. I'd love to get feedback. Does this sound right? Is this a good way of ranking boats? Giving them a prize at the end of the season for the best performance profile boat has a pretty little chart. You can get it on your t-shirt and have Esprit. Actually I shouldn't look. Shall I look at Esprits? Okay, I'll look at Esprits. NYC 32. Okay, I'll cop it. Anyway, I think that's probably enough to show. The site is, if we go to the documentation, is sailing.mortbait.org. It's running on a Raspberry Pi. Be gentle. All the source code is at GitHub. This video will be made available through this link, which you probably followed already. I've done, the AI has written a fair bit of documentation and some detailed design documents of how everything works. If you've got feedback, it's on GitHub. By all means, raise issues on GitHub, ask questions, tell me I'm an idiot, whatever, put it all there. If you can help me improve the data by merging boats, editing boats, merging designs, editing designs, that would be great. If you can't find the right buttons for that, just raise an issue and we'll see where this goes. It may be useless, it may be useful. Feedback's welcome. Anyway, thanks a lot. I shall talk to you later. Ciao.